So yeah, let's dive into back to school with CodeHS. So right off the bat, if you haven't signed up for an account yet, now would be a good time. You can just go over right there to codehs.com/signup, enter your info, choose your school, and then you should have full access to this feature that we're about to show. And so while you're doing that, I'll just kind of dive in and talk at a high level before even entering the CodeHS site around what a debugger is and what is debugging. So this is actually not a tool that CodeHS invented in any way. This is a much larger kind of classification of tools in computer science, in software engineering, in coding in general. Most development environments and most programming languages will come with a debugger. So what is a debugger? A debugger is really any tool that allows you to test your program in a very specific way and debug your program in a very specific way by allowing you to stop execution of the program at a specific point that you defined. Once it's halted, you can kind of look around, you can print out the values of your variables, and you can start stepping line by line through the execution to see where the program goes. A lot of times this can illuminate some misunderstandings. It can show you that your program execution is going to a place you didn't think it was going, or it can show you kind of the state of your variables, what values are stored in your variables at this point in the program. Maybe you thought they were holding different values. And then once you actually get in there and start printing things out, it can really help in the debugging process. So a lot of programming languages come with this. Python actually comes standard with a debugging tool called PDB. Java comes with one called JDB. And those are actually the exact debugger tools that CodeHS is using. CodeHS has just made some buttons and some nice user interaction around it so that you're not sitting there typing in every single PDB or JDB command. You can actually just kind of press buttons and kind of animate your code as we step through, which we'll see in a sec. But that's a debugger. They're awesome. They're really cool tools, and we'll see what they look like on CodeHS today. So how can we enable the CodeHS debugger? So the step debugger, specifically in Python 3 and Java, is a new feature that's only available in the newest IDE, the newest development environment on CodeHS. And so to have this always available, we'll actually want to switch our preferred IDE from original to Abacus. So Abacus is what we're calling our latest code editor, our latest development environment. And if you're curious to learn more about all of the features that are new and available in this new editor, we're going to have another webinar tomorrow, actually, that's introducing much more than just the debugger. The debugger is one of many features that are really awesome and available in Abacus. But to get to your account settings, you can either use this link here in the slides, which we'll send out later, or we can just go over to, let's let this start from the beginning. Just in the upper right corner, you can click your name and choose account settings. And then from here, we want to go check out the IDE settings. We want to have our preferred be Abacus as opposed to original. This will ensure that for any of those Python 3 or Java programs, you're in the latest development environment, which includes the debugger. Sweet. So that's how we enable it. Again, this will be available. These slides will be available, and there are help articles available on CodeHS later. So you can always come back to this. Thank you, Gary. Okay. So once we have that turned on and we enter any of our programs, whether that's CodeHS curriculum or whether that's curriculum you've created or whether that's the CodeHS sandbox, if we were to open a Java program, for example, we should now see these editor settings, this little gear icon on the left. That'll open up this whole settings panel. And among these settings are debug mode. And debug mode is the mode that we want to flip on, and that'll introduce some new options to running the program, including step, next, and continue. And so these are debugger commands. As we'll see in a moment, I'll kind of demo what each of these commands do. But this is kind of the process for entering debug mode when you're actually in the editor. So with that, we should go ahead and dive in and try it. So this link will take you to a CodeHS tutorial that has some videos, has some examples, has some text to walk you through how to use the CodeHS debugger specifically in Python. So I'm going to go ahead and press on this link, and we can check out the Python debugger tutorial. And we'll just kind of walk through this together as a group. Gary, can you see my screen or is it still on the slides?
We can see you on the browser.
Great. Okay. Awesome. And so again, that's how we enable the debugger. But right off the bat, we come to a quick little example here embedded right in the tutorial. I want to show this in the full editor. So I'm actually just going to fork this into my own sandbox rather than messing around with it here. We could run it here, but I'm going to go ahead and fork it so that we just have a bit more space. So now I should be able to open this in my sandbox. All righty. So before we even try debugging this program and try using debugger, let's see what this does. This is a Python 3 program. It has 3 functions: main, say hello, say goodbye. The main function looks like is going to define a name Carol, say hello and goodbye to that name, and then define another name Tracy. And then in a for loop that's going to happen 3 times, it's going to say hello and say goodbye 3 times to Tracy. And so if we just run this, we see, boom, a bunch of goodbyes and hellos. But if we use the debugger, we can actually slow down and see how this program is stepping through the execution as we go. So long as I'm in the latest editor, which here I am, I should see this, this settings icon here. So I'm going to choose that and just enter debug mode right here. Now that I've done that, I see it actually have a few more options here. Before it was just run and stop. Now I have step, next, and continue. So right off the bat, just to get this program up and running, let's do run. And we see that now, instead of finishing the whole program immediately and speeding through it, we're actually stopped at the very first opportunity possible. We're stopped at that first line. We're about to define the main method, the main function. If I step, that will step to the very next execution, regardless of which file that lives in or which function that lives in. That is opposed to next, which will go to the next line in the current function. So we'll play around with that in a sec. But the way Python works is it's actually going to first define each of these and then call the main function. So if I step, boom, main is now defined. Step again, say hello is now defined. Step again, say goodbye is now defined. So now I'm paused right here, about to call the main function. If I were to step, I'll actually enter that main function. I'll step into the main function. If I were to next, then I would step over it. I wouldn't actually go inside the main function. So in general, step is what you're going to want to use to actually see that line by line execution flow. If I were to continue, it'll just blow through the rest of the program, continuing without stopping. So maybe let's see that real quick. I can continue and we see, boom, the entire program just ran and now it's restarted. So I'm back at the beginning. So that's continue. I can do it again, just ran again. But let's actually dive in and see the more interesting flow, which is actually stepping into that main function. So I'm going to step, 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 go ahead and step into that main function. So here we go. Now I'm inside main and I can see line by line what Python is doing as it runs my program. So I can step here. And just to exemplify the difference between step and next, instead of stepping in to the say hello function, I'm actually going to next. And next will not enter into any function calls. It'll just go to the very next line in the current function. So if I do next, I'll end up on line 4 right there. I'm now at say goodbye. We've already called the say hello function and we see that we've printed out hello Carol. You may notice there's a lot more output coming out here than just my program's output. So this little PDB right here, that is the built-in Python debugger. We're showing all of that output from the Python debugger just to show you what you would see if you were professionally developing Python and running this in a terminal. This is all of the output that the debugger is providing to show you where in the program you are, what the instruction is that you're on, and then the previous commands that you've entered. So this right here is my program's output. Everything else is PDB's output. Okay, so I've nexted over say hello. If I were to instead step, it'll actually enter me, boom, into that say goodbye function. So here I am in say goodbye. I can go ahead and execute that one line inside say goodbye, and now it'll return me back to the call site. So this is just a cool way to kind of step through the program and see what's happening at each line. So I can just keep using step here to go line by line through the entire program. Yeah, And if I'm satisfied with this, if I feel like I have a good idea of the flow of this program, I can continue, finish the program, and it'll take me back to the top. So that is our first example. That's the difference between step and next. But there is a lot more that this Python debugger can do. So I'm going to go ahead and exit this example and go back to the tutorial and keep going here. So we've talked about step, next, and continue. And here's our next example. So we can actually import functions from other files, and the debugger will automatically switch us between files in the code editor. So let's see that. Let's fork this one to our sandbox. And we'll check out the difference between step and next with a little more detail. So here, my main file simply calls say hello to Carol, say hello to Tracy, say goodbye to Carol, say goodbye to Tracy. These are not defined inside my main file. So they're actually imported from this other file. If I check out that, here's where those helper functions actually live. Here's where they're defined. Say hello will print out hello to whatever name is passed to it. Same thing with goodbye. So if I run this, I should expect to see hello Carol, hello Tracy, goodbye Carol, goodbye Tracy. But if I go into debug mode, I can actually see as execution hops back and forth between the two files. So I'm going to run this again. It's going to stop me right on that first line. I'm going to want to next over any import statements. If I step and I get stuck inside some Python library code as I'm stepping through all of this import, Python's doing a lot of work to actually import those files. So I'm just going to stop there, rerun it, and next over that line. Boom. So now I'm not bothering entering into any crazy Python library code attempting the import. I can just next right over that. And just to see the difference here, if I use only next, I should cruise right through this file, just going from next line to next line to next line without stepping into any functions. So we got hello Carol, hello Tracy, goodbye Carol, and next for goodbye Tracy. And now we're back to the top. So let's try that again. This time I'm actually going to step. So if I step into say hello Carol, we see that it's now taken me to that other file, and it's taken me to the function definition for say hello. So actually, I can actually see the code inside there and step through it and see if maybe this is where my bug lives. Is this where my program's getting weird? Keep stepping. We see we call say hello again. Now we're about to call say goodbye, step into there, and so on. So that's the process for step versus next. And we can see that the debugger automatically hops you between files and highlights whatever line is about to execute, which is really nice. Cool, so that's that example. Let's see if there's any Q&A questions so far. No, sweet. So that's that. And now let's talk about printing out the values inside your variables. So we have another example for that. Let's keep going. This is a program that defines a phone book dictionary, mapping the name Carol to Carol's phone number, the name Tracy to Tracy's phone number, and the name MJ to MJ's phone number. And what this is going to do is it's going to loop over every name in the phone book and print out their number. And then in a for loop 5 times, it's going to get a random name and print out that name and what value we are in the loop counter. So if we enter debug mode with this, we should be able to kind of stop at various points in the program and see the value of each of those variables as we go. So let's try that out. Again, we'll go to settings, turn on debug mode. And now when I run, it'll stop at the first chance it gets. So it's going to stop at that import statement. I'm going to go ahead and next over that. Next, 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 as we define the phone book. Great, now that's defined. And now let's next into this for loop. So here we are in this for loop. I have this variable name, but I have no idea what's held inside of it. Like, what is the order that Python is iterating through this phone book? Who knows? Well, to see the very first name that is pulled from the phone book as we're for looping through the phone book, I can actually just type Python commands here. So let's go ahead and print out that name. Awesome. So Carol is the first name. That makes sense. Let's try printing out the value of number. Ooh, we see it's not defined yet. So I'm on this line, but it hasn't executed yet. So the variable name number does not exist yet. Let's go ahead and step. Now it should. So if I try this again and just print out number, boom, we see Carol's number right there. So it pulled it out of the phone book, which is awesome. So I can go next from there. Next. Let's try this one more time. Print out the name. I'm guessing it's going to be MJ. Yep, it is. And I can print out the number. Great, we get MJ's number. Sweet. Looks like we have a chat. Yeah, Gary's got that in the chat. So let's continue out of this for loop. Boom. So now we're entering the next one. Let's go next. We can step in to get a random name. And so now we've entered this other file, the utils file. I can step from here to go into the get random name function. I've defined these names in a list. And now here's another one of those tricky Python situations where pressing step can kind of get you stuck inside library code. So random.choice, that is not a function that I, as the student, wrote. That is a function that I imported from the Python standard library. If you were to step here, you would end up stepping into that Python library code, which isn't that interesting. That's not where your bug is going to live. So there's really no reason to step into any function that you didn't write. So instead of stepping here, I'm going to do next. So now that that has run, I have a random choice, and we're about to return it. So let's go ahead and do next to return it. Sweet. And so now we've called that random name function, entered into it, run all of its logic, and we've come out of it with a new name. Let's print out what that name is. Sweet, Carol. So that is the name that ended up getting pulled out of this, randomly out of this list. And from there, I can do next. We'll print out both Carol and the for loop counter. So we saw that that for loop counter was a 0. Let's step again and check out what that for loop counter is now. I'm guessing it's going to be a 1. Nice, it is. And that's the idea here. So as we're stepping through the debugger with our step and next commands, at any point, we can choose to print out the value of any variable that exists at that point in the program. If we try to print a variable and we find that it doesn't exist yet, that means we have to keep stepping in order for it to exist. So let's just continue there. And we see that, okay, we printed out the rest of our random names as well as the for loop counter. Cool. So that's a little crash course on printing out and seeing what's inside your Python variables as you're stepping through your program. So that's it for that example. The final thing I want to talk about when it comes to debugging Python is breakpoints. So breakpoints are awesome. Up until now, every time we've run our program, we've gotten stuck on that very first line. And then we had to step to get to the place in the program that we were actually interested in. Breakpoints let you define a specific line that you want to stop on. So if you kind of have a hunch thinking, okay, maybe the bug in my program is going to live in this file or it's going to live in this function, you can set a breakpoint. And so execution will continue up until that point and it'll stop exactly where you want it, which is really nice. So to see breakpoints in action, let's go ahead and fork this example to my sandbox. You should be able to fork all of these to your sandbox as well if you want to do this and start tweaking them. And so the way a breakpoint works is you just click on a line here, a line number. If you're not in debug mode, nothing's going to happen. But if we go into our editor settings, enter debug mode. So now we have our nice little debugger commands again. Now, if I click on any of these line numbers, we see I get a little stop sign that comes right up next to that number. So let's start with this. We'll set 2 breakpoints, one on line 3, one on line 7. And now, actually, let's do line 4. So one on line 4, one on line 7. This time, when I run the program, boom, it stops right on line 4, which is really nice. I didn't have to step up to that point. So now we're stopped here. I can print out, let's see what the value of num names is. So we got 5. That makes sense. I just defined it right there. Shouldn't have changed. And now what's really cool, I don't even have to step from here or next from here. I can use continue and it will continue execution up until the next breakpoint. So if I continue, awesome. Now it landed me on line 7. So now I'm inside this for loop. I can print out the value of I to see what iteration I'm on. Okay, 0. I'm on the very first iteration. And now I can continue again. Boom, it stopped again. So these breakpoints keep living on, even if you've already hit them. So breakpoints in a for loop are really nice because they allow you to keep stopping at that same point as you iterate through the for loop. So now I can print out I again. You see that I'm at iteration 1. Let's do continue. Print out I again. Now I'm on the 5th iteration or value 4 because it's 0 indexed. So those are breakpoints. One thing to note is if I remove it here, I I have to stop the debugger and restart it. So anytime you go to change your breakpoints, you'll need to stop and restart in order for those changes to take effect. But once I've done that, now we see that all those breakpoints earlier were cleared, and now I just have one on line 6. So I can just do next, 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 continue from there. It'll keep stopping there as the for loop hits it. All right, so those are breakpoints, and then you don't have to worry about clearing them if you just leave debug mode. They'll all get cleared. So that is a little crash course to using the Python debugger. Definitely encourage you to check out this tutorial. Right here, there's videos, there's examples. You can fork all of these to your own sandbox and start tweaking them. But this is a good starting place for playing around with all of the features of the Python debugger. If you're curious to learn more, so this isn't some fancy CodeHS homegrown tool. This is the industry standard Python debugger, also known as PDB. And so I've linked to the PDB documentation right here. Anything in the PDB repertoire, any command that PDB knows, you should be able to type into the CodeHS editor and use it as is. So these are all the commands that we covered today: step, next, and continue; print, which prints out the value of a variable; and break, which sets a breakpoint. So those are the PDB commands that are available through the CodeHS editor. But if you want to do your own research and check out the other cool features of PDB, you can always type those into the CodeHS runner as well. And those will all work. All right, how are we doing on time? It's doing pretty well. Want to make sure I leave a chance for any Q&A questions to be answered. Looks like we're good. We have a question: do students in my class have access to this? Yes, they do, as long as they no, so a teacher setting your own IDE preference. So if I go to my own account settings and set my preference, that does not affect my students. Your students will have to go to account settings and set their preference as well. A lot of times it will, if they're working through the CodeHS curriculum, they should be seeing the latest editor anyway. But just to ensure, just in case they're not, and they're still seeing the original editor, that will be the fix, is having them go to their account settings and switch their preference to the new one, to Abacus. So if they're not seeing that in their settings, that would be what you would guide them to do, is go to their account settings, switch it, and then yeah, it should be available to students as well. This isn't just for teachers. Correct. Yeah. Okay, awesome. So that's Python. And if you were curious about seeing it in Java, then buckle up, because we're going to see it in Java as well. So we go back to the slides. We have a similar tutorial, here for debugging in Java. So I'm going to open that up. Cool. And the good news is it is super similar. A lot of these ideas around pausing, stepping, step, next, continue, breakpoints, these are universal ideas across languages and across debuggers. So everything we learned to use in the Python debugger, that is going to be available in the Java debugger as well. But there's just a little bit of nuances with debugging Java compared to debugging Python. And so we'll go over that together. What else do we have in the chat here? Sweet, thanks, Gary. Okay, so right off the bat, in this tutorial, you can always come back to this. There's videos, there's little examples. I'm going to go ahead and fork this first example to my sandbox, so we can play around with it in my sandbox. I just use that little fork button right there. Sweet. Okay, so here we have a Java program. It's got two files, myprogram.java and student.java. So if you're unfamiliar with Java, the way Java works is you define classes in Java, a Java class. In this case, it's the student class. And these classes have properties about them that you can set. And they have their own methods, aka functions in Python, methods in Java, that you can define and then call these methods on instances of the class. So in this case, we have a student class. A student consists of both a name, like Calvin, and a class name, like AP Java. We can construct a student, and then we can call student.toString, which returns a kind of string representation, a text representation of the student. If we go to my program, we see that, okay, I've made a few student objects. I've made first student, second student, and third student. And then I have a for loop that's printing them out. So if I just run this, it's going to blast through the program and finish it all without showing me the process of hopping back and forth between files. I just now have these three students. They got printed out 4 times. If I want to instead kind of slow this down and examine what's happening line by line, same deal. I go to settings and I turn on debug mode. Now I see those exact same buttons. But now if I step through my code, I'm going to shorten this a little bit. If I run this, we will stop at the first chance we get. So that's usually going to be the very first line of your main method or your run method if you're using console program. And so here I am, I'm on that very first line. And same deal, if I use next, I will not step into any deeper logic. I will just go to the very next line in the current function. So if I press next here, we've now run line 5, first student is now defined, and I'm about to define second student. But I blew through a lot of logic between line 5 and line 6. If I want to see what's going on there, I can actually step into the student constructor and see what's going on. So here I'm making a new student with name Tracy and with class web design. So I'll step in and boom, we see it's taken me to that student file. I'm about to execute the student constructor. So populating that name, populating that class name, and now we're going to go ahead and return back to the call site. Sweet. So now here we are back in our main method. We can do that again for student number 3, populate name, populate class name, and return. And now we have all 3 students populated. And I can just go on and next from here, and it's going to print all of them out. Boom, boom, boom. Same deal. We're seeing a lot. We are seeing my output from my program, but then we're seeing a bunch of JDB output as well. So this is kind of the industry, whatever standard output that you have to read through if you're using JDB professionally. You're seeing a lot of extra info that can be really helpful, but can be noisy as well. And so that this is all of the output dumped from the Java debugger. So I'm feeling like I have understood the flow of execution here, and I like, oh, this is interesting too. So you may not know this, but when you print out a Java object, you are implicitly calling the toString method. So to print out second student, let's step, and we see, ooh, actually this toString method did get called, even though I didn't explicitly say second student dot toString. Java automatically inserts that in order to print out a nice string representation. So that's a little Easter egg that we're now visualizing thanks to the debugger, which is cool. So that's something very Java specific. If you don't teach Java, you don't have to worry about that. But yeah, that's a cool thing that the debugger can help visualize. So feeling comfortable with this, I'll just continue, finish the program. We printed out the rest of my students and the application now closed. Unlike the Python debugger, Java doesn't automatically restart. So if we wanted to see it again, we would just press run again. And now we're back in it. Sweet. So that's our first Java example. We've seen step, next, and continue. Let's move on and check out. We could see another example of step, next, and continue. So that's what's in this tutorial. Let's fork this. Okay, so here we just have a single file. My main method is going to call say hello twice and say goodbye twice. I run this. This is the output I would expect. Cool. But let's go ahead and enter debug mode, and we can see this flow of execution a little better. So if I run this, it's going to stop at that very first line. And watch the difference between using only next and only step. If I use only next, I'm never going to leave that main method. I'm just going to power through it and finish. But if I use only step, then I'll actually step into that say hello method. Boom. And so now I'm executing that line of say hello, return to the call site, step into say hello, return to the call site, step into say goodbye, return to the call site, step into say goodbye, return to the call site. So next can really help you visualize stepping into all of these Java methods that you've written. And unlike the Python debugger, you don't really have to worry about stepping into library code. The Java debugger is smart enough to know that you probably don't want to step in there. So if I did have something like, import java.util.star, and then I had some, some Java, I won't exemplify it here, but Java debugger should not step you into library code, which is really nice. You can kind of freely use step without worrying about getting stuck in library code. Okay, so that's step versus next. And let's keep going and talk about printing variables. So there are 2 different commands here in Java. because Java is so object oriented and we're making not only primitive values like ints and strings, we're also making these complex objects like the student class that I showed you earlier. Print is going to print out whatever the string representation is. So for objects, that's the result of calling toString. Dump will actually pick apart that complex object and show you all of the values stored inside of the object. So a lot of times dump is what you want to use if you're trying to like really see the entire picture and the entire state of the objects that you're defining. So let's go ahead and see that in an example. I'll fork this. And so same deal here, that same student class, we see that as a student is a complex object that itself contains two strings, a name and a class name. If I use print, I'm going to get this. I'm going to get that nice little string representation. If I use dump, then I'll actually see, I'll kind of see the guts of this student object. I'll see what's stored inside. So let's enter debug mode. Run this program. We're going to stop at that first line. And right off the bat, let's try printing out the value of first student. Ooh, it says first student is null. It doesn't exist yet. So let's go ahead and step through this constructor and go back to the call site. Okay, so now we've defined first student. And now if I try printing the value of first student, I shouldn't get null. I should instead see, okay, Carol is in AP Java. So that is the string, the toString representation of this student object. But if instead I want to actually dive in and see all the values stored inside, I could dump first student. And we see that here we go. First student contains a name, Carol, and a class name, AP Java. Sweet. So that's the difference between print and dump. Imagine I had an object with 10 or 20 like private variables, private instance variables. Dump would allow me to see all of those, whereas print may not. So that's what's nice about the dump command. Similarly, we can just next through here. Let's try dump third student. And there we go. We see all the values stored inside there. And then let's go ahead and get into this for loop just to show what it's like to print something else. So we now have this other variable present in our program, I. We can print out the value of I. I'm expecting it to be 0 because I think we're on the first iteration. Yep, so I is 0. If we try to dump I think we'll get an error. Oh, no, that works too. Just prints out I is 0. Awesome. So that is the strategy for exposing the value of your variables as you're debugging your Java programs. You got the print command, you got the dump command. We'll stop that and let's check out our next example here. So likewise, just with Python, if we want to avoid stopping at that very first line and having to step to the point that we're interested in, we can always set breakpoints in Java programs as well. It's the exact same strategy. We're going to enter debug mode and then press a line number to set a breakpoint. So let's go ahead and fork this. So we have a lot of different files here. We have console program, randomizer, my program, and students. This program looks like it's going to enter a for loop. So in this case, 3, and 3 times it's going to create a student and print it out. Cool. So if I just run it, it's going to blow through that entire program. So it's made 3 different random students, Carol, Carol, and Tracy. Let's go ahead and set some breakpoints here. So I don't really want to stop on that first line. I would really like to stop maybe right before I create the student and maybe right before I pick the random grade. So I'm going to stop on line 9 and on line 20. Now that I've done that, I can run. It's going to stop me right on line 9. I can print num students and see that that's already defined. I didn't have to step to that point. And from here, great. So I'm checking this out. We can even continue. Awesome. And so it brought me down to that next breakpoint. We've now called this create student method. We're inside of it. We've ran all of these lines already, and now we're about to run this random grade. So I print random grade. Doesn't exist yet, but if I next, now it should. Let's try printing it out. Cool. So it generated a random grade of 12, and I'm about to return it. I can step from here to go back into that student constructor, step, back to the call site, and let's continue. And we see that we've now printed out that random student, Calvin is in grade 12. Yeah, so same deal here. If I wanted to remove this breakpoint, I would need to stop the program. So if I continue here, that breakpoint still lives on, but stopping the program and restarting it will update those breakpoints. So now that this is my only breakpoint, line 20. Cool. All right, so those are breakpoints in Java, very similar to breakpoints in Python, and they're just a good way to get really specific and say, I actually want to stop on this exact line. And you can set as many as you want, as many or as little. And you can also set them across multiple files. So we could have one here, and then maybe another one here. And switching back and forth should maintain those. Okay, cool. So that's that example. Similarly, with user input. So this is a gotcha with Java. If you've gone through the Java course, you know that to accept user input in a Java program, you need to make a scanner object. And that scanner usually says scanner equals new scanner system.in. So that's how we accept input from the keyboard. The Java debugger, unfortunately, is it blocks that. It interprets any input as a command to the debugger, as opposed to input intended for the program. PDB does not have this issue. With Python, you can feel free to accept input from the user as much as you want, even in debug mode. But in Java, we need to be a little more clever. So I'll show you how to get around that. Let's fork this in our sandbox. And normally we would do something like this. The scanner system.in. When we run, I can provide a number 10 and a number 20, and then we get the product right there. If we were to try doing this in debug mode, let's see what happens. Okay, so we're here. Let's continue. It wants us to enter a number. Let's try 10. It's saying, ooh, unrecognized command 10. So JDB isn't smart enough to figure out that it needs to pass along that 10 to the program. So instead of using system.in, all we have to do is manually type in the input that we intend to give it. So this is a really common strategy with debugging. You're going to control the inputs that are given anyway. And so this is a way for the programmer, for the student, to define what the inputs are going to be. So instead of, while the program's running, type in a 10 and a 20, I'll provide a string that's a 10, a new line, and a 20, and a new line. So now the scanner is just going to eat through this input as the program runs. So now if I run this, hit that breakpoint, and we can just do next, 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 next. Go ahead and print out the value of X. We see that it's 10. Print out the value of Y. We see that it's 20. Sweet. So continue from there. We see the product. Yeah, so that's just what that's a common strategy for providing input to Java programs that are running in the JDB environment. And that's just what we have to do here. We just have to feed it a string. Cool. So that is providing input with Java. And as always, if you're curious to learn more, these are the commands that we covered in the JDB tool set. Talked about step, next, and continue. We talked about the difference between print and dump. And we talked about the stop command, which sets a breakpoint at a specific line. But like PDB, JDB has a lot of really cool features. If you want to learn more, you can go read the JDB documentation from Oracle. And those commands should work if you just type them into the CodeHS runner. But yeah, that is a really awesome new feature that I'm really excited about. A lot of teachers have been asking about it for a long time. And so now we can finally pause your program wherever you want and kind of animate those lines as it executes, just like you can in Carol. We can now do that in Python 3 and Java. So that is our presentation here. Thank you all for coming. If you ever want these resources again, this video will be available. This webinar will be available. There's a nice help article here for using the debugger, and both of those tutorials that we just worked through, those are available here as well. So these are always some good resources to come back to. And even more general CodeHS resources if you're interested in really diving in and becoming a CodeHS expert, supporting other teachers, maybe running local workshops in your area. We have a whole program to become a CodeHS certified educator. So read through our CodeHS help docs for more information about that. We have a CodeHS educators Facebook group that's really active, really lively. A lot of awesome educators supporting each other and using CodeHS. So it's a great Facebook group to join. If you're interested in more of these free CodeHS PD sessions or teacher-led workshops, check out